Hi guys, welcome back. So in this lesson, we're going to be looking at how to do scatter plots. Scatter plot is a plot that illustrates the relationship between two variables, an x variable and a y variable. And we use a scatter plot when we think there's likely to be a correlation between two variables and we want to visualize that correlation. So in this example, the main theme is going to be modernization theory. Modernization theory says that as countries become wealthier, they're more likely to be democratic. Okay, and we're going to use some data to illustrate modernization theory with some scatter plots. So why don't we go ahead and get started? We'll go here to our Quarto file, put a heading, scatter plots. We'll say we are going to start out by generating some data for our scatter plots. And the way that we're going to do that here, let's put a code chunk in there and we'll label it, let's call it SP data just for scatter plot data. What we want to do is we want to read in the data from the last module. We want to read in the demwomen.csv file. We're going to read that into an object that we're going to call dem summary country, because we're going to summarize these data by country rather than region like we did in the last module. But we can do that by modifying the file. So let's go ahead and read CSV data /dem women.csv. All right, and then we'll put a pipe operator, and we are going to group by both country and region. Okay, so basically this is going to summarize the data by country, but by also including region in the call here, it will keep the region indicator in the data, and we're going to want that because we want to basically add region as a dimension to our plot. So you'll see what I'm talking about in a little bit. So let's go ahead and put another pipe operator there, and now we're going to call summarize, and we're going to just basically do the mean of each of these variables. Remember, we want to remove NAs when we're calculating the mean. Okay, so let's look this over. So we are reading in data /dem summary.csv from our data folder here, and we are grouping by country and asking dplyr to also include the region indicator or region label, and then we are summarizing. We're taking the mean of all of our variables. Okay, so that should work. Let's go ahead and run that. Let's go ahead and glimpse it. Glimpse dem summary country. Yes, so this looks good. Afghanistan, Albania, Algeria, Angola. So we have one country. These are the correct regions for those countries, and then we have one observation for each of those countries. Okay, and there's 181 rows, 6 columns, so that looks about right. It would have removed the NAs, so 181 countries sounds about right. Okay, so let's go ahead, and from there we'll write a little more text here. Now we are going to make our first scatter plot and see whether modernization theory is true. All right, so let's go ahead and build the scatter plot. Let's label this first scatter plot. And let's go ahead and do our ggplot call. That's our data. Here's our mapping. X equals GDP per capita. Y equals polyarchy. Color well, actually, let's just do X and Y right now. And our geom for scatter plot is going to be geom point. Okay. And we can go ahead and just run that and see what happens. And we do get a scatter plot with GDP per capita here on the x-axis and polyarchy here on the y-axis. You see something of correlation, but notice that a lot of the data are bunched up over here towards the y-axis. Okay. Okay, we're not going to worry about this warning here. One thing we can do is that if we're getting warnings and we're not too concerned about them and we don't want them to appear in our Quarto document, we can include a chunk option that is warning colon false, and that way when we run it, it doesn't give us the warning. The other thing that we can do, maybe we'll explore a little bit more later on, is we can say here execute, and then we can include up here as warning false. That will apply that chunk option to the entire document, so we don't have to write it in the individual code chunks. Okay, so now the next thing we want to do, because we're seeing all of these points kind of bunched up on the y-axis here, what we can do is we can stretch that x-axis, right, so that these points, we can stretch it on a log scale essentially so that these points are more evenly distributed. And that's a very common thing to do when we're dealing with economic data that are, skewed. So let's go ahead and use a function called scale underscore x underscore log 10. All right. And then let's just go ahead and run that. You can see what that looks like. All right, so that's much more evenly distributed. And we can see there a pretty good correlation. There's some outliers down here that we'll talk about later, but there's a pretty good correlation between wealth and democracy when we stretch the x-axis that way. Now, the next thing we notice is that these labels are not very informative. What is 1, 10, and 100? And remember we said earlier that these values represent thousands. So this 1 is really 1,000, this 10 is 10,000, this 100 is 100,000. So what we want to do here is, in order to make these the values of these x-axis labels more apparent, like what they represent more apparent, is we want to use a package called the scales package. Okay, and there's two ways that we can use the scales package. We can do the traditional thing where we load the scales package with library scales, okay, and then all of the functions associated with scales package will work. But what I want to show you here is a different way of calling scales. So we can go ahead and say labels equals scales colon, and that tells R that we want to use the scales package, some function from the scales package. And the nice thing is when we use the scales package this way is that we get this auto-populated list of functions associated with the scales package, and sometimes they're hard to remember, so it's nice to have this list. And what we want here is label underscore number. Okay, so we're going to select that one, and that's going to take two arguments. Prefix equals $, and suffix equals K. So we're going to put a $, after each of these numbers, and a K afterwards to signify that they represent thousands of dollars. Okay. So let's go ahead and run that. And there you can see we have our relabeled x-axis, relabeled figures on the x-axis. Okay, so let's go ahead now and pretty this up a bit. Let's first of all add some labels. Our x is going to be GDP per capita. And we're going to leave it like that for now. Let's go ahead and run that. And that's looking pretty good. Okay, but maybe we are curious. We want to know, like, what, is there sort of a uniform relationship between GDP per capita and polyarchy? Or are there some regions, perhaps, where that are outliers? Okay, and what we can do to kind of get at that is to add a third dimension to our plot. Color equals region. Let's go ahead and run that. And now we can see a color coding of the different regions in our data set. All right, so this is why it was important to keep region in the data frame when we were doing the summarize up here. Okay, so we can see that these countries bunched up here are the Western countries. They have very high levels of GDP per capita and very high polyarchy scores. We have African countries kind of bunching a little bit down here in the southwest quadrant of the plot. The other countries from other regions seem to fit on this line pretty much, but the outliers, the real outliers here, are Middle Eastern countries. And this may have to do with the resource curse, which, for a variety of reasons, undermines democracy. Okay. Last thing I want to do here is I want to include a fourth dimension to our plot. We're going to say size equals women underscore representation. So we're going to adjust the size of these points now based on levels of women's representation to see how that maps on to both GDP per capita and the polyarchy score. And this is sort of interesting. So we actually see that the variation with respect to women's representation is greater within regions than it is across regions, right? So we see, for example, in Africa, we see some countries that have low levels of female representation, some that have high levels of female representation. Same thing in almost every region that we look at, except for maybe the West, where there are pretty much uniformly high levels of female representation, maybe with the exception of, it's kind of hard to tell because they're so bunched up. We know that United States is a bit of an exception there relative to, say, for example, Western European countries. But it gives us a nice picture here and an ability to make some hypotheses, at least, about how women's representation maps onto these other two variables. Okay. Okay, so now I want to take a step back a bit. We're definitely seeing here some sort of correlation between wealth and democracy, but let's dig into that a little more. First of all, how can we tell how strong this correlation is? And an easy way to do that would be to include a trend line. So let's go ahead and copy this, and let's paste it down here. And let's say, now we will add a trend line to our plot, and we're going to add, change the label here, trend line, and let's take out women's representation in region from this first mapping here, and let's go down to geom point. And let's add a new AES call, and let's put color equals region in that, because basically what we want to have here is we want to have a plot where the dots are colored by region, but the line is across the but the trend line that we're going to draw is going to be for all of the points. And if we leave color equals region up here in this first aesthetics mapping, then what it's going to do is it's going to draw a different trend line for each region. Okay, and maybe I'll take a second and show you how that's true in just a little bit. But first, let's go down here and let's add a geom smooth. So this is going to be the trend line that we want to see, and method equals LM, which stands for linear model. Line width equals 1. Okay, and let's not forget to add the plus sign there. And let's go ahead and run that. Oh, it didn't like something. I forgot the comma here. Okay, so this looks pretty good. That's exactly what we wanted. We have the trend line here, and we can see that this trend, you know, this relationship looks like it's pretty strong. So this is a line, and this is a regression line essentially, and this is a confidence interval. And we can see that the confidence interval is definitely defining a difference between, is definitely showing us that there's a difference, a statistically significant difference between countries with high GDP per capita and low GDP per capita in terms of their polyarchy score. So that's a pretty good indication that there's a correlation. Notice here that we're getting a message, and we may not want that in our output. So let's add another code chunk option here, message false. Okay, and let's run that again and see if that takes care of that. Yep, there we go. Okay, so what I was saying earlier was, let's say we take AES color equals region out of here, and we just put color equals region up here. What happens then? See, that looks kind of ridiculous. We get a different trend line for each region. So that's why we want our color equals region to be here in the geom point call. All right. Last thing I want to show you here is that rather than a linear model is not the only kind of model that you can have in terms of your trend line. So we can also have, for example, a low S curve. And there are other options as well, and I refer you to the documentation to explore some of those options. But this is what it looks like with a low S curve. Okay, and sometimes that's useful if there's a lot of sort of, it's not a straight linear relationship between X and Y. We might want to explore other alternatives. But here, a linear model actually looks pretty good. Okay, a couple other things I want to show you here. First, I want to show you facet wrapping. And what facet wrapping is basically, instead of showing our regions, you know, we see that there's a difference between the regions here. And we might be interested in looking at that a little more closely. So rather than just color coding the regions, we may want to have actually a separate plot for each region. Okay, and the way to do that is not to have them, you know, a different trend line for each region in the same plot. We actually want to have separate plots. So how do we do that? One way to do that is with a facet wrap. So let's go ahead and copy our code chunk, label it facet wrap. Let's say here now, let's do a facet wrap to show differences, to show how the relationship between wealth and democracy differs across regions, or what are the heterogeneous effects of wealth on democracy, is another way of putting that. So next we're going to take out the color equals region. We're not going to color by region. Instead, we're going to facet wrap. So we're going to take that out. We're going to leave this the same. And then we're going to add down here facet wrap. And then we need a tilde. And we need to tell it what variable we want to facet wrap by. And that's going to be region. Okay, so essentially instead of color coding by region, we're facet wrapping by region. All right, and everything else should stay the same. We could take this out because we're not going to be using color equals region anymore. Take out that comma, and let's run that and see what that looks like. All right, so that looks pretty good. So now we can see definitely there's a clear relationship between wealth and democracy in some regions and maybe not so much in others. So Eastern Europe, there's a clear relationship. Asia, there's a clear relationship. Latin America, Middle East, definitely not a relation. It's kind of hard. Africa, it's kind of hard to tell what's going on there. It doesn't seem like there's a clear relationship there. Maybe because there's a lot of underdeveloped countries, so there's not a lot of variation in terms of wealth. With respect to the West, everything's kind of bunched up. And so one thing we can do here is we could actually add an option here to our facet wrap call. We could say scales equal free. All right, and if we do that, then there's actually an option just to make the scales for X free or the scales for Y free, but we're doing both here. And then everything's on a different scale essentially, right? And this allows us to unbunch the West. And there we see something of a relationship between wealth and democracy here, but we can see that a little more clearly when we facet wrap. But the problem is, we have a trade-off here. It's a little bit harder to see what's going on in general when we have each region on its own, Y scale and X scale. Let's just go back here real quick to the previous call without this free scales, and here you can see it's just a cleaner plot, right? It's easier to see what's going on. So there's definitely a trade-off there. Okay, one last thing here that I want to show you, which is about labeling points. Now we will explore labeling points. So for this, what we're going to do is we're going to filter, first of all. We're going to take a step back here, and we're going to start with dem summary country. And we're going to filter by region. We're going to just keep Asia for this example, but we could do it with any region, really. All right, and now we're going to do our ggplot call. We're not going to facet wrap. All right, so all the rest of this is going to stay the same, but what we're going to add here is geom text. What this is going to do is it's going to allow us to use the country names as labels for the points. So we're going to go AES label equals country, and then we can change some other parameters, like we'll have size equals 2 and the vertical adjustment will be 2. Okay, and then remember to add our plus sign. Right, and that should give us a nicely labeled points in our plot. Actually, one thing I forgot to explain here was that we are actually piping our data here into the ggplot call here. So we don't, and so what I neglected to do was to delete out the data argument here, because we don't need it, because we're actually telling ggplot here what data we want through this pipe operator here. So actually that's another way that you can use ggplot that's really kind of cool, right? You can just use pipe operators to pipe the data into the ggplot call rather than including it as an argument in the function. Okay, so let's go ahead and run that. Okay, so that's what that looks like. Here we have a scatter plot, GDP per capita on the x-axis, polyarchy score on the y-axis. We have all the countries in Asia. We can see this relationship between wealth and democracy in Asia, and we can see here the country names that are nicely placed next to the points. Okay, that's all we have for this module, for scatter plots and for this module. Let's go ahead and we'll go back up here, and as per usual, we'll save everything, and then we'll go ahead and render our document just so we have some nice HTML output to look at. And there we go. There is our HTML module 2.1 document.